Okay, here's a couple good gas law questions. It says a gas occupies 45 liters, that's a volume, at 2 atmosphere pressure and 27 degrees Celsius. 27 plus 273.15. I think that's 300.15. 300.15 Kelvin. Calculate its volume at STP. So standard temperature and pressure. Standard pressure is 100. Oh, hold on. We need atmospheres. It's 100.00 kilopascals, but I have to have the same unit. Let's not use that. So standard pressure, I want to say is 1 atmosphere. I think standard pressure is 1 atmosphere. And then temperature at standard pressure is 0, so that's 273.15 Kelvin. Okay, looks like they're not changing how much gas, so that's a wash. Don't need that. Now, so if they half the pressure, the volume's got to go up, right? Yeah, because they're inverse, pressure and volume. So the volume has to go up. So my answer can't be 41. 910 is way out to lunch. So it's got to be one of those 3. If I'm guessing, temperature goes down a little bit. I don't know. 45 times 2 is 90. I don't think it's the 81 one. I don't know, I'm just guessing. But let's use our formula. P1 V1 over T1, P2 V2 over T2. And I'm looking for V2. So V2 is P1 V1 T2 over T1 P2. So my first pressure is 2 atmospheres times the first volume, 45 liters, times the second temperature, 273.15, over first temperature, 300.15 Kelvin, times P2, 1 atmosphere. Okay, so let's do that on the calculator. Okay, just did it on my calculator. I was wrong. It comes out to 81.9. Let's see, atmospheres cancel, Kelvins cancel, liters, 81.9 liters. It's that one right there. All right, here's another question. A vessel with an internal volume 11.6. Okay, let's do our thing again. P1 V1 N1 T1. 11.6 liters. Contains 2.8 grams of nitrogen gas, 0.430 grams of hydrogen, and 79.9 of argon. At 25 degrees Celsius, okay, I think that's 298.15 Kelvin. I think that's right. 273.15 plus 25. Yeah, that's right. I put the volume in the wrong spot. The volume is 11.6 liters. So it looks like they're giving me a bunch of moles. Well, they're giving me grams, but I can convert those to moles. And so then I have to figure out what the total pressure is. So this looks like a Dalton's law. So let's figure out the number of moles for nitrogen, the number of moles for hydrogen, and the number of moles for argon. And then we can add those together according to Dalton's law, and then determine pressure using PV equals nRT. So let's do our moles up here. So moles are equal to mass over molar mass. And for nitrogen, the mass is 2.80 grams. And the molar mass of nitrogen is 14.01. but it's N2, so there's two of them, so that'll be 28.02 grams per mole. Okay, so I'm going to come up with a number for that. And then we'll do hydrogen, moles, same thing, the mass 0.403 grams divided by the molar mass of hydrogen. Hydrogen is 1.01, but since there's two of them, that'll be 2.02 grams per mole. Grams cancel. That'll come out to something. And then argon. Argon, moles is equal to 79.9 divided by argon. What's argon? I have to look that up. 39.95. I think that comes out exactly to 2. Okay, let me calculate the other ones. Okay, so I figured out the number of moles of each of those. Now, because mole or gases behave the same, I can just add up all of those moles. So I'll do that. So I need to add that plus the first one, 2.8 divided 28.02. Oh. Okay, plus 2. So, and I did this without rounding, so it's 2.2994, etc. moles. So that's the total number of moles of gas that I have. So now I can use my PV equals nRT. I'm searching for P, so I'll divide both sides by V. So nRT over volume. So the number of moles is, is 2.2994, etc. moles, and the number I still have in my calculator, times R is 8.314 kilopascal liters per Kelvin mole, times the temperature, 298.15 Kelvin, and divided by the volume, 11.6 liters. So my liters cancel out, my moles cancel out, my kelvins cancel out. I'm left with kilopascals. Perfect, that's what I need. Okay, calculator. Okay, I'm back. So on my calculator, that gives me 491.36895 kilopascals. Do they have that answer? Oh, great. They want atmospheres. Okay, we can do that. Let's write that down. So 491.36895 kilopascals times, there's 101.325 kilopascals in, they want atmospheres, 1 atmosphere. So I have to take that number that I just got and divide it by 101. So 491 point, I should have kept the number in my calculator. Divide 101.325. So that's given me 4.84934 atmospheres. So they have one close to that? 4.85. Oh yeah, that would be exactly it right there. Okay, hopefully that helps you with those two questions.